NASA's 370-mile camera fix, heating JunoCam to save Jupiter mission. *** miracle repair 370 million miles away, how NASA saved the Juno probe's ailing camera ***. Imagine capturing the breathtaking beauty of Jupiter's moon Io, only to have your trusty camera malfunction at the worst possible moment. This was the daunting scenario facing NASA's Juno probe, but here's where ingenuity kicks in. By harnessing the power of heat, NASA managed to revive the ailing JunoCam not once, but multiple times, defying the harsh conditions surrounding the gas giant. ***, the initial fix, a moderate warm-up ***. The first signs of trouble with JunoCam prompted NASA to employ a novel solution. By gently warming the camera to a moderate 25 degrees Celsius, the initial issues were resolved. However, as the eagerly anticipated close flyby of Jupiter's moon Io approached, the camera again began to show distressing streaks and noise in its images. ***, turning up the heat, a dramatic turnaround ***. With time of the essence, NASA decided to crank up the heat to the maximum possible temperature. Days later, in a dramatic turnaround, the image quality improved significantly, just in time for the Io flyby. The stunning photos of Io, captured during this close encounter, are a testament to the success of this unorthodox repair method. ***, the extreme environment of Jupiter ***. More than 2 years ago, NASA first disclosed issues with JunoCam, but details were scarce at the time. The space agency had initially been cautious, only confident that the camera would survive 8 flybys of Jupiter due to the planet's extremely damaging radiation conditions. As errors in the transmitted images escalated, NASA turned to an innovative solution inspired by materials science, the annealing process. This controlled heating and cooling technique, known for repairing defects in materials, proved remarkably effective for the JunoCam. ***, a technique born from necessity, now a valuable asset ***. Emboldened by the success of this approach, NASA has since adapted the annealing technique for other Juno instruments and subsystems. Although the probe has now completed 74 orbits of Jupiter and recently experienced a return of image noise, the lessons learned are invaluable. According to Scott Bolton, Juno's principal investigator, these insights will benefit not only future NASA missions but also commercial and military satellites. ***, the Juno probe's prolific journey ***. Since its arrival at Jupiter 9 years ago, the Juno probe has been orbiting the gas giant, uncovering a wealth of information. Key discoveries include the unexpected strength of Jupiter's magnetic field and the notable differences between the planet's north and south poles, which were previously unexplored. Additionally, Juno has significantly contributed to our understanding of Io's volcanoes. With the mission extended until September 2025, there's still more to come from this intrepid explorer. ***, but here's where it gets controversial. ***, could this annealing technique be the standard emergency fix for future deep space missions, or are there potential risks we're overlooking? Share your thoughts. Do you think NASA's approach to repairing JunoCam in space sets a precedent for innovative troubleshooting in the cosmos? Stay informed. Follow us on Facebook, LinkedIn, or Mastodon for the latest updates and insights into the world of technology and space exploration. Originally published in German. This article has been translated and editorially reviewed for your convenience. How NASA's Juno saved its camera from Jupiter's deadly radiation. Amazing space repair mission. Imagine the sheer audacity of fixing a camera millions of miles away in the harsh radiation belts of Jupiter. That's precisely the incredible feat NASA's Juno spacecraft achieved, ensuring its JunoCam didn't become a victim of cosmic radiation. Launched in 2011, Juno embarked on a mission to unravel the mysteries of Jupiter's origin and evolution. Navigating through the solar system's most intense radiation fields, JunoCam, the spacecraft's color, visible light camera, started showing signs of strain by December 2023. The mission team on Earth faced a race against time to devise a remote solution before losing the opportunity to photograph Jupiter's moon, Io. The solution, surprisingly straightforward, involved heating the instrument and then gradually cooling it down, a bit like the classic tech advice of turning it off and on again. This ingenious move not only saved JunoCam but also offered invaluable insights into spacecraft radiation resilience, as highlighted in a recent Jet Propulsion Laboratory statement. Initially, scientists anticipated that JunoCam, positioned outside the protective radiation vault, could withstand radiation for the first 8 orbits around Jupiter. However, it wasn't until the 47th orbit that the telltale signs of radiation damage emerged. The team pinpointed the voltage regulator, crucial for JunoCam's power supply, as the affected component. With limited options from afar, they opted for a less conventional method called annealing. This process involves heating a material to reduce defects and then slowly cooling it. We were aware that annealing could impact silicon at a microscopic level, but its effectiveness in fixing the damage was uncertain, shared Jacob Schaffner, a JunoCam imaging engineer from Marlin Space Science Systems. We instructed JunoCam's heater to raise the temperature to 77 degrees Fahrenheit, 25 degrees Celsius, much higher than usual, and waited anxiously for the outcome. Their strategy initially paid off, enabling JunoCam to capture clear images for several orbits. But as Juno continued to plunge into Jupiter's radiation fields, the damage resurfaced. By orbit 55, our images were riddled with streaks and noise, recalled Michael Ravine, JunoCam's instrument lead. We tried various image processing techniques, but nothing worked. With Io's close encounter looming, it was a desperate Hail Mary moment. Our last resort was to crank up JunoCam's heater to its maximum and hope for the best. Initially, the extreme annealing seemed ineffective. But just days before the Io approach, the images dramatically improved. On December 30, 2023, JunoCam captured stunning, detailed photographs of Io's North Polar region, revealing previously unseen volcanoes. This remarkable achievement was presented at the Institute of Electrical and Electronics Engineers Nuclear and Space Radiation Effects Conference in Nashville on July 16. And here's where it gets controversial. NASA's secret hack: how they fixed Jupiter's camera from 370 million miles away. Imagine this: NASA faced a critical issue with one of their cameras orbiting Jupiter, and they had to perform some ingenious remote hardware hacking to fix it. This isn't your average tech support call, we're talking about fixing a camera 370 million miles away from Earth. But here's where it gets truly fascinating. NASA launched the Juno spacecraft to study Jupiter, equipped with a visible light camera called JunoCam. Initially, the camera was expected to last for about 400 days, or 8 orbits of Jupiter, due to its placement outside the protective radiation vault. However, the engineers weren't overly optimistic about its longevity because of potential radiation damage. Miraculously, JunoCam exceeded expectations and functioned well for the first 46 orbits. But on the 47th orbit, it began showing signs of radiation damage, particularly in the power supply's voltage regulator. Sending a replacement part to Jupiter was out of the question, given the vast distance. So, the team at NASA's Jet Propulsion Laboratory had to think creatively. One solution they considered was annealing, a process involving heating and cooling materials to potentially fix microscopic defects. Jacob Schaffner, an imaging engineer from Marlin Space Science Systems, explained, "We weren't sure if annealing would work on the silicon components of JunoCam, but it was worth a shot." They instructed the camera to heat up to 77 degrees Fahrenheit, significantly warmer than its usual operating temperature. To everyone's relief, the technique worked, and JunoCam started capturing clear images once more. However, the improvement was short-lived, and the camera's performance declined again. The team experimented with various image processing methods but found no success. Undeterred, they decided to try annealing a second time, this time pushing the heater to its maximum setting. Once more, their efforts paid off, and JunoCam produced high-quality images, just in time for a close encounter with Jupiter's moon Io in late 2023. The success of these annealing experiments led NASA to apply the technique to other Juno instruments and engineering subsystems. While the agency didn't disclose the outcomes of these additional tests, Scott Bolton, Juno's principal investigator, emphasized the valuable lessons learned. Juno is teaching us how to build and maintain spacecraft that can withstand radiation, which will benefit satellites orbiting Earth and beyond, he noted. Unfortunately, JunoCam's troubles weren't over. Image noise returned during its 74th orbit, and the future of the camera remains uncertain. Will NASA attempt another round of annealing? Only time will tell. This story highlights the innovative problem-solving skills required for space exploration. But here's a thought-provoking question: could these remote repair techniques be applied to other distant missions, or are they too specialized for Juno? Share your thoughts in the comments.